Alright, good morning everyone. Welcome to lesson 4F. Today we'll be talking about negative and zero exponents. Now you're probably wondering why in the middle of quadratics we are talking about exponents. Well, in chapter 4 we've noticed so far that the quadratic function has three different forms represented. We've got the vertex form, the factored form, as well as the standard form. Now the standard form, once again, gives us, which is right here, our y-intercept. Our factored form gives us our x-intercept. And our vertex form gives us our vertex. So putting all three together gives us very key three important pieces of information in order to graph our parabola, or our quadratic function. Now, in chapter 5, we will be focusing on how to convert between those three forms. So it will be very algebra heavy. But before we can even do that, we need to review and understand how exponents work. Because evidently, as you can see here in the standard form, we are dealing with x squares. In other words, the exponent is no longer just a 1. Okay? So, with that being said, we need to understand how to work with exponents in order before we can dive into chapter 5. So think of this as a precursor to chapter 5. So this very well could have been put in the 5th chapter, but instead the textbook decided to end chapter 4 with this, which makes sense as well. Okay, so before I dive into any of this, I want to just quickly review the exponent laws, which I'm going to put up here. Okay. Actually, you know what? I'm going to assume you've never heard of any of the exponent laws, and I'm going to start fresh. Okay, so then we will slowly, throughout this lesson, develop the exponent laws. So take a look at our first expression. Now, you can take out your calculator if you would like, and you could type this in your calculator, and you would get an answer of 4. So, how would you get that? Well, you could simply type this in. 2 to the exponent of 3 is the same thing as 2 times 2 times 2, which will give you 8. 2 to the exponent of 1 is just 2, and then 8 divided by 2 will give you 4. Okay? Now, expanded form. Well, what do I mean by expanded? Well, this is, think back to grade 6 math, grade 7 math. If you take the numerator, which is 2 to the exponent 3, how do I write that in expanded? Remember the long, tedious way that we never do, that we haven't done since elementary school? So 2 to the exponent 3 is the same thing as 2 times 2 times 2. 2 to the power of 1, which is the denominator, is just a single 2. Well, what does that equal? Well, you can see that these two will cancel, right? Which will give us simply just whatever is in the numerator, which is just 2 times 2. Now, how do I write that as an exponent? Well, it's 2 to the exponent of, how many of them do I have? Well, I multiplied it by itself twice, and that will give me 2 to the exponent 2, which we know is indeed 4. Now, the question is, how do I get from here to here? Okay? Well, some of you would have realized that, wait a minute, the base stayed the same, 2, 2, 2, the base being the big number. And what happened to the exponent? Well, since we divided it, 3 minus 1 is 2. Okay, so I'm just going to write that to the side here. I'm going to choose x. Let's call this exponent a to represent any number, divided by x to exponent b, again just represents any number. If I were to divide two variables with the exact same base, the base stays the same, and what happens to the exponents? Well, since we're dividing, we subtract the exponents. Okay, so as you can see here, this rule applies and it works. So using the exponent laws, we can say 2 to the exponent of 3 divided by 2 to the exponent of 1 is equal to 2 to the exponent of 3 minus 1, which is the same thing as 2 to the exponent of 2, which is 4. Okay, so let's try the second example. Same thing. So in expanded form, this is 2 times 2 times 2 3 times in the numerator. And in the denominator, it's 2 times 2. Okay, so since I have two sets there, so I can cancel that 2 with that 2, that 2 with that 2. Well, what am I left with? Just a single 2. Okay, so that's an expanded form. 2 to the exponent 1, sorry, just to be more specific. Now using exponent laws. So 2 to the exponent of 3 divided by 2 to the exponent of 2 is equal to 2 to the exponent of 3 minus 2, which is just 2 to the exponent of 1. And that's just 2. Okay, and they both check out. Let's do a few more. Yeah, so let's try this one. So in this case, the numerator is 2 times 2 times 2. And then same thing with the denominator. Okay, now look what happens here. Well, that cancels with that, that cancels with that, that cancels with that. So what does that give me? Well, I have 2 to the exponent. How many times is it multiplying itself by? If I move up. In this case, 2 to the exponent 1 is because I have 2 left over. That's why there's a 1. In this case, it's 2 times 2. There's 2 2's left over. That's why there's a 2 there. Well, in this third case, it's 2 to the exponent. How many 2's do I have left over? 0. But what does 2 to the exponent of 0 equal? Well, this is telling us that I have no 2's left over, right? Let's backtrack a little bit. If I look back here, if I wanted to solve this, what do I get? Well, 2 to the exponent 3 is 8. 2 to the exponent 3 is 8. Any number divided by itself will give you 1. That's right. If you have 8 friends and 8 cookies, everybody gets 1 cookie. Well, then that means 2 to the exponent of 0 must then equal to 1. And if you don't believe me, take your calculator. In fact, and this rule will be true for all exponents of 0. So 2 to the exponent, standard, no, scientific, there we go. Okay, so 2 to the exponent of 0 will give me 1. In fact, I can generalize that case and pick any number. So 2, I don't know, I'm just picking a massive number. 2 to the exponent of 0 will give me 1 again. Now, why does that work? And this right here explains why that works. Because if it's to the power of 0, that means, as we saw here, the number of 2's, or in this case, whatever our base is, and if our base is 2, then it's 2 times 2 times 2, blah, blah, blah. That means the number of 2's I have in my numerator would equal the number of 2's I have in my denominator, which means they'll all cancel out. So if they all cancel out, that means the numerator divided by the denominator will be this exact same number, which will give us 1. Okay, so if I can generalize that case, I'm going to move this down for a second. So 0 exponents. A, any number. So I'm just going to point at this. Any number to the exponent of 0 will give you 1 all the time. Okay, so let's just go back here. And if I use the exponent rule, exponent laws, same thing. 2 to the exponent of 3 divided by 2 to the exponent of 3 equals 2 to the exponent of 3 minus 3, which will equal to 2 to the exponent of 0, which will equal to 1. Okay. Alright, moving on. Let's try this one. Let's see what happens here. So there's 3 in the top. 2 times 2 times 2. And there is 4 at the bottom. 2 times 2 times 2 times 2. Okay. So the same rule applies. Let's see what happens. So that will cancel, 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 that will cancel. Huh. Well, what happens here? The top, I end up with, well, there's no 2's left over, right? Now, if I backtrack a little bit, would I put this number is divided by 0? No, this is divided by 1. Okay? Any whole number we can assume is divided by 1. Okay? Same thing here. This is also divided by 1. Now it's a 1 because everything, the 2 canceled out, 2 canceled out, which means it's just a 1 underneath, right? Now if I look over here, the 2's cancel out, the 2's cancel out, the 2's cancel out. So if that's the case, then I only have a 1 on top and a single 2 at the bottom. So I end up with 1/2. Is that true? Let's backtrack. Again, 2 to the exponent of 3 is 8. 2 to the exponent of 4 is 16. Is 8 over 16 the same as 1/2? It sure is. This does indeed equal to 1/2. Does that make sense? It sure does. Now let's take a look at the exponent rule. So 2 to the exponent of 3 divided by 2 to the exponent of 4, that would be saying 2 to the exponent of 3 minus 4, which gives us 2 to the exponent of -1. So does that mean 2 to the exponent of -1 equals to 1/2? Let's take out a calculator and see. So 2 to the exponent of -1 is equal to, oops, I just typed in 2 minus 1. 2 to the exponent of -1. No, let's try that again, sorry. I'm getting used to this computer calculator. So 2 to the exponent of 1, which they want it to be negative. So 2 to the exponent of -1 will give me 0.5. And isn't 0.5 a half? It sure is. Okay? So let's do one more before we try to generalize this rule. So once again, 2 to the exponent of 3 divided by 2 to the exponent of 5. What would that give me? Well, again, 3 on top, divided by, and then 5 at the bottom. Okay. So to cancel, I got 2's cancel out there, 2's cancel out there, 2's cancel out there. And then what do I get? I get 1, because all the 2's are gone, divided by 2 to the exponent. How many are left over here? 2 of them. 2 to the exponent 2. Does this mean this? The solution to this expression is 1 over 4? Well, let's find out. 2 to the exponent of 3 is 8. 2 to the exponent of 5 is 32. Is 8 over 32 the same thing as 1 over 4? Well, 8 divided by 8 is 1. 32 divided by 8 is 4. It sure is. 1/4, 1/4. Now let's see what this means using exponents. So 2 to the exponent of 3 divided by 2 to the exponent of 5 is the same thing as saying 2 to the exponent of 3 minus 5, which is the same as saying 2 to the exponent of -2. So does that mean 2 to the exponent of 2 is the same thing as 1 over 4? Or, better yet, it's the same as that? It sure is. So, let's generalize this rule quickly. If I just scroll down, if I look at that, okay, how do I generalize this rule? Well, since it's a negative exponent, this just means, if I look back here, that it brings the base to the bottom, as you can see here. So 2 to the exponent of 1 will be the same thing as 1 to the exponent of 2 to the power of 1. So right now you can see this is technically over 1, right? This is in the numerator, the negative exponent brings it down. Okay. Or it brings it either down or up, depending on where it is. And I'll show you what I mean by that in a second. So in this case, 2 to the exponent of 2, technically this is over 1. This will become 1 over 2 to the exponent of 2, and the exponent becomes positive. Okay? And you can see here, here's proof that it's true. Okay, so let's just scroll down and generalize this rule. So a to the exponent of negative n would equal to, again, this is technically over 1, so I would bring this down, 1 over a to the exponent of positive n. Okay, so and if I, just to clarify this a little bit more, I'm going to provide a couple of quick, simple examples. So if I have 3 to the exponent of negative 2, now, just to type that in the calculator to find out what we get. Actually, no, before you do that, let's just utilize the rule we just learned. So since the exponent is a negative 2, that will be the same as saying 1 over 3 to the exponent of positive 2, which then will give us 1 to the exponent of 3 squared is 2. 3 squared is 9. So that will give us 9. 1 over 9. Let's see if that's true. So 3 to the exponent, 3. So 3 to the exponent of negative 2 will give us 0.11111. Is that the same as 1 over 9? Let's find out. 1 divided by 9 is equal to 0.1111. And there you have it. So let's take a look at a couple of these examples. Express the following as whole numbers or fractions in lowest terms. So 4 to the exponent of negative 2 would be the same thing as saying 1 over 4 to the power of 2. Oops. 2. That's it. Or, you know what, lowest terms, sorry, I can simplify this one more. So that would be the same thing as saying 1 over 16. So if you type this in your calculator, you would get 1 over 16. 14 to the power of 0, it's always going to be anything to the power of 0 is 1. Okay, now if I multiply these, let's see what I get. Now, let's just add in one more exponent rule here. So if I were to multiply exponents with the same base, okay, instead of, let me just scroll up to the top here. Instead of subtracting the exponents, we would be adding them. So what do I mean by that? So let's say we had x to the exponent a times x to the exponent b. That would be equivalent to xa plus b. Okay? So it's very similar to when we divide two variables with the exact same base, we subtract the exponents. Whereas if we multiply with the exact same base, we add the exponents. Okay, so let's scroll back down and let's take a look at this question. 5 to the exponent of negative 6 times 5 to the exponent of 4. Now the base stays the exact same. Okay, the base would never ever change. In fact, if the bases are not the same, none of these exponent rules apply. So here we have negative 6 plus 4. This would give us 5 to the exponent of negative 2. Now what do we know about negative exponents? This will end up flipping to the bottom, to the denominator. Okay. Now sorry I ran out of space here, but your final answer here would be 1 over 25. So if you type this in your calculator, you would get 1 over 25, or whatever 1 divided by 25 gives you. Okay, next one, same thing. This would give us 1 over 2 to the exponent 5, and so forth. Okay, now you can figure out the rest of these on your own. There is one I want to bring your attention to just to make sure that you remember this one last exponent rule. Sorry. Okay, and that's this one right here. What happens when you have an exponent on an exponent? Okay, so I'm going to add this one last exponent rule to the top. Right here. So this one last exponent rule is if I have an exponent, A, and an exponent on another exponent. Okay, so let's assume this is A. So what happens then? Well, the base, once again, stays the same, but you don't subtract them. You don't add them. Instead, you multiply them. Okay? Multiply them. So let's scroll back down. And if I take a look at this right here, since I noticed that it's an exponent on an exponent, the base stays the same, and I would have negative 1 times 3, which would give me 8 to the exponent of negative 3. Negative 1 times 3 is negative 3. And that would give me 1 over 8 to the power of 3. Okay? So those are all the exponent rules. I'm going to choose one of these hard ones to do, because I'm sure you guys might have questions about them. So let me just... Let's pick 2 of these ones. So let's take a look at C. Are the bases the exact same in all 3 of these? Yes, they are. So I can put this as y to the exponent of negative 4, since I'm multiplying them, plus 2 plus negative 1. Okay? And that will give me y to the exponent of negative 2 subtract 1. And my final answer would just be 1 divided by y to the exponent of positive 3. Okay? Let's take a look at this one. Base is all the same? They sure are. So let's break this down to steps. Let's first work on the denominator, or sorry, the numerator in this case. So I'm going to take a look at just that for now, and that will give me 7 to the exponent of, what's 2 times negative 1? Negative 2 times 7 to the power of 4 divided by 7 to the power of 7. Okay, so again, all we've done so far is multiply 2 times negative 1. Okay, to get negative 2, because it's an exponent on an exponent. Then, I'm going to, since we're multiplying the numerator here, we can add the exponents, so negative 2 plus 4 divided by 7 to the exponent of 7. And I'm just copying this bottom part down. The denominator stayed the same. Okay. Now I'm sorry, I'm going to have to carry over here. So now, if I add those up, what do I get? Well, negative 2 plus 4 is negative 2. And this is 7 to the exponent of 7. Okay. Now, since it's a negative exponent, this goes down underneath. So I get 1 over 7 power 2. Okay, so this has been brought underneath because it was a negative exponent up here, now it's a positive. So this went into the denominator. Now this 7 to the exponent of 7 didn't go anywhere, did it? It's still there. Okay, so one last step then. 1 divided by, well in this case, the denominator, the bases are still the same. It's both 7, right? So I can just add the exponents. What's 2 plus 7? 9. And your final answer is 1 divided by, or 1 over 7 to the exponent of 9. Of course, you can go one step further and find out what 7 to the exponent of 9 equals, but it's a big number and I won't be able to fit it in here. Okay? If you have any questions, please feel free to post under math questions, and I will produce a quick video. Now, if these exponent rules you have not seen before, okay, please comment under math questions, and I can quickly create a video that just focuses on these 3 rules. Okay, the 2 rules that are supposed to be new in this video are these 2: the zero exponents and the negative exponents. Okay, all right. See you guys.